Hello, grade 11s. Good morning. How are you today? This is Patrick Kamala. I am a tutor and educator for mathematics, grades 9 to 12. Today, I want us to start with exponents and the surds. This is our first video for the lessons of 2022. Okay. Now, exponents and the surds, we have got the laws which govern exponents and the surds, and I want us to start from there. Okay. Now, these laws, they are from grade 10, but we have to revise them so that we understand them properly. Now, the first one says that if you have a to the power n multiplied by a to the power n equals to a to the power m plus n. Okay, in other words, if you have the same base, and you're multiplying, then you're going to add the exponents. Like you see, the a is the base here, another is the base here. So you're going to say equals to a power m plus n. Okay, that's if we are multiplying.
Daddy, I want a chippy.
And
Daddy,
then
this one is for buying chippy.
And then if we have I'll now take an example here for this one here. This is the example. Take an example of 3 to the power 3 multiplied by 3 to the power 4. You see, because we have the same base, which is 3, it means we can simply add what? The 3 plus 4 to give us 7. That's why our answer here is 3 to the power 7. Let us proceed. And next one. Now, if we are dividing the exponents, as in if you're dividing a to the power m divided by a to the power n, because we have the same base, which is a in this case, we are going to subtract the exponents. Like it's going to be a to the power m divided by a to the power n equals to a to the power m minus n. Okay, let us look at the example here. For example here, as you can see, if I have 2 to the power 8 divided by 2 to the power 4, because I have the same base and I am dividing, what do? I subtract the exponents. I'm going to subtract 8 minus 4, which gives me 2 to the power 4, which is the same as what? 16. Okay, I hope we are still together. Let us proceed. Now, if I have open brackets a to the power m close brackets a to the power n, in other words, a to the power m to the power n. Okay, now in this case we open brackets and multiply the exponents. Okay, so as you see, this is a to the power m, then power n, the same as saying a to the power m multiplied by n. And we can also swap them. We can interchange. We can put m outside brackets, then put n inside the brackets. So the same as saying also a to the power n and the power m. A good example is this one here. An example is this one here. If I have 3 to the power 3, then power 4. The same as saying 3 to the power 3 times 4, which gives me 3 to the power 12. And it can also be written as 3 to the power 4 and then the power 3. Okay, so that is it, guys. Let us proceed here. Let us proceed. Now, if I have a product in brackets, then to the power m, like 8 multiplied by b to the power m. Now, this power is going to become a power to all the products, all the variables in brackets. It's going to be actually a to the power m multiplied by b to the power m. Okay, let us take an example here to show how we use it. Now, if you check here my example, I have open brackets 3x power 4, then y power 3, close bracket squared. Ne? So this square is for the whole brackets, ne? Meaning that it is also for the 3, also for the x power 4, also for the y power 3. Ne? So now this is 3 is the same as 3 power 1. So this 2 is going to multiply the 1 to give me 3 power 1 times 3, and then dot x power 4 times 2, like we said before, and then dot y power 3 times 2. Okay, so if I simplify this further, what do I get? Now 1 times 2 is 2, and then 3 squared is what? Is 9. That's why I put 9 here. And then 4 times 2 is 8, as I've got x power 8. And then 3 times 2 is 6, as I've got y power 6 here. That's my answer. I hope we are together. Let us proceed here now. Now another row here which we have is if I have a over b, that's a quotient, né? A divided by b to the power m. Now again, this power is going to be distributed to the numerator and the denominator, né? So it's going to become as a to the power m divided by b to the power m. Let us look at an example here. An example here we have is, as you see here, I've got 4 over x squared. Now then power 3, né? So this 3 is for the numerator, which is 4, as well as for the what? Denominator, which is x squared. So it's going to be 4 to the power 1 times 3, then divided by x to the power 2 times 3. 1 times 3 is 3, and the 4 power 3 is what? Is 64. Likewise, 2 times 3 is 6, so I get my x power 6 here as my answer. Hope we are together. If we are not together, please pause the video or replay it again. Let us proceed. Now, because of those rows, we have what we call as the definitions of exponents, which are called as the corollaries. Ne? Now, the first one we have here is a to the power 0 is 1. Now, this a is a real number, which is not 0. Ne? So, any real number to the power 0 gives us 1. Take an example here. The example here, which we have is 3 power 0 is 1. When it is 1 million to the power 0, it also gives us 1. Okay, that's a definition we have in exponents. Another definition here we have a to the power 1 to the power a is also 1, whereby a is a real number. Take an example. Now that as long as this is 1, even if this a is 2, 3, 10, 20, 40, as long as it is a real number, okay, it means it's gonna give us 1. Note, a cannot be a negative and a cannot be a fraction. Okay, let us proceed here. To see the example, if I have a to the power 2008, it gives me 1. 1 power 2000, it gives me 1. Maybe somebody can say, but why do you say like that? It's because now 1 power 2000 is the same as saying 1 times 1 times 1 times 1 times 1 until you multiply 2008 times. So we see we get 1. That's why the answer there is 1. Okay. Let us proceed. Another definition here. Now if I have x power negative n, you see my exponent is a negative here. Ne? Now if I write it as a fraction and put it over 1, the exponent becomes positive. In other words, x power negative n is the same as 1 over x power positive n. We have an example still here to clarify this. Now if I have x to the power of negative 4, and I put it over 1, it's going to be 1 over x to the power 4. That's another definition which we are going to encounter as we proceed. Please understand it as well. Okay. Now, if I am multiplying a coefficient by x power negative n, now this negative exponent only affects the variable. In other words, the a remains in the numerator, and then this negative n becomes positive when it goes into the denominator, so it becomes a over x power n. For example here, if I have 3 to the power negative 3x power negative 4, now the negative 4 is only for the x, so the 3 remains on top, then divide by what? By x power 4. Don't forget, when we had x power 4, it was the same as 1 over x power 4. Okay. Now here the coefficient was 1, that's why it's 1 here. Now if our coefficient is 3, it's going to be what? 3 over x power 4. Let us proceed. Hope we are still together. Now if I have a bracket, then like ax power negative n in brackets. Now because the power is, they have put a bracket, it means that the exponent is for both a and x in this case, so it's gonna be 1 over a times x to the power n. We have an example as well. Here. Now if I have 3x power negative 4, it's the same as saying as 1 over 3x power 4. You see, so this 4 is affecting the whole brackets, okay. Please understand that definition as well. Okay, now if I proceed here, and I have 1 over x power negative n. Now, if this one leaves the denominator and goes in the numerator, it becomes a positive power. That's why this is x power n. Okay, an example is this one here as well. If I have 1 over x power negative 4, you see, now it's in the denominator, so when I take it in the numerator, it becomes x power 4. Please understand the definitions. Okay, now another rule here which we have. If I have a over x power negative n, now the a was already in the numerator, and it is positive, so it remains as it is, but the negative exponent becomes positive in the numerator, so it becomes a times x power n. For example, again here, if I have 3 over x power negative 4, it's going to be what? It's going to be 3 multiplied by x power 4. Hope we are together. Let us proceed. Now, another rule which we have in exponents is when I have 1 over x power negative n, now there is no brackets here, so this negative n is for x only, so it's going to be the same as x power n over a. You see, now the a has remained in the denominator, because there was no bracket here. However, if there was a bracket like in here, everything was going to go in the numerator and the exponent becomes a positive. Okay, look at examples here. Now check this out, guys. You see here there's no bracket, so this is 1 over 3x power negative 4 becomes x power 4 divided by 3 because there was no brackets here, but if I put a bracket like in this case here, now because of the brackets, the 3x as well goes in the numerator to give us 3x power 4. Hope we are together, guys. Let us proceed. Now another one which is also important if we have a over b bracket to the power negative n, now to make this power a positive, we swap the numerator for the denominator. In other words, the numerator becomes denominator. What about the denominator becomes what? Numerator. And that's why it is b over a but the power positive n. Okay, hope we get together, guys. What I'm saying, this one comes here. Okay, it comes here, and then the b comes here. But then the what? The power becomes positive. And that's why it is b over a to the power n. Take an example here as well. Take an example here. So if I have 3 over 4 to the power negative 2, to make it positive 2, I have to swap the 3 and 4. Becomes 4 over 3 to the power positive 2, like that. Just like that. Just like that. It will never change. If you get it now, that will be much better. Okay. Now, lastly, if I have a to the power negative m divided by b to the power negative n, now don't forget that this b power negative n is in the denominator. So when it goes in the numerator, it becomes a positive power. Likewise, this a power negative m is in the numerator. When it goes in the denominator, it becomes what? A positive power. Take an example here, guys. I have an example here. Now this is x to the power negative 3 divided by y power negative 4. Now because it's a negative power, it becomes a positive in here. And this negative power becomes a positive in the denominator. Okay. Okay, don't forget what I said. The x and the y, they are swapping. Actually, we're using the same rule like we did up there already. So this power negative 4 becomes power positive 4 because it's getting from the denominator and going where? To the numerator. And then this power negative 3 becomes a positive because it's going to the what? To the denominator.
Daddy.
Okay, so because of that, we have, because of this, we have some example here. Simplify the following. Now try to identify the laws that we use here. Now take here, we have got 3 a squared multiplied by 3 a power 3 multiplied by b power 0. Okay. Now if you take what we said already, now by the way, here we first multiply the coefficients. We're going to say this b power 0 is same as 1. Think about what we said, same as 1. Now this is 2 times 3, which is 6. And then as you see, this is a, this is a. It's the same base. Because I am multiplying a squared by a power 3, I'm going to add the exponent. So it's gonna be 6a to the power 3 to the power 2 plus 3, then times 1. Okay. This is 1, this is 1 here. Then times what? Times 1. So we have something like this. It's going to be 6a to the power 3 plus 2 times 1. What is 2 plus 3? It is 5, and then times 1 becomes, it remains, of course, it remains 6 to the power 6a power power 5. That's my answer there. Let us proceed. Another example here. Another example. So now example B, check here. If I have 3 power 5 multiplied by 3 multiplied by 3 power 3 divided by 3 squared multiplied by 3 power 6, and in this case, as you can see, I have the same base. So now because there's nothing here, you can say the same as saying there is power 1 here. Okay, power 1, don't put 0, just use 1. Okay, so here I have 3 power 5 multiplied by 3 power 1 multiplied by 3 power 3, and because I am multiplying, what do I do, guys? I add the exponents. I add what? The exponent. That's why it's going to be 3 power 5 plus 1 plus 3. Likewise, in the denominator, I'm going to add 2 plus 6 to give my 8. Now, 3 plus 5, that is 6, plus 3, that is, 5 plus 1, that is 6, plus 3 gives me 9. What about 2 plus 6 is 8. So, now because I'm now dividing the 3 power 9 by 3 power 8, I do what? I subtract the exponent to give me what? 3 power 1. Hope we are together. Let us proceed. Let us proceed. Next here. Now, I have a brackets here, don't forget. Bracket negative 3, a power 3, then b square, bracket square, then divided by what? By a power 5, b power 3. Now, this is square, this power is going to affect all the terms in the brackets here. Like you see, this 2 is going to come, it's going to power the negative 3, and then also this 2 is going to power the a power 3. Also, this 2 is going to affect the b as well. It affects what? The b as well. So now, guys, talk to me. What is negative 3 squared? What is what? Negative 3 squared. So now when we say negative 3 squared, what does that mean to us? If we say negative 3 squared, we actually mean what? We mean negative 3 multiplied by negative 3. We mean what? Negative 3 multiplied by negative 3. So what is negative 3 multiplied by negative 3? What do we get? We get positive 9, okay. We get what? Positive 9. So, and then because these are two exponents now, that means that it's going to multiply the 2 to give me 6, So it's going to be 9, okay. Then a to the power 3 times 2 is 6, okay. And then 1 times 2 is 2. So then b to the power what? B to the power 1 times 2, which is 2, okay. Then divided by what? Divided by a to the power 5, and then b to the power what? B to the power 3. So now, as you can see, I have got a b in the numerator as well as what? Denominator. So it means, and I've got the a's as well. So that's the same base, So in this case, I'm going to have what? I am going to have my rows applied here. Okay. Now check this out. Check this out here. This is what I did. And then if I check this, because I have 9a power 6 b squared divided by a power 5 b power 3, I look for the same bases. In this case, it's a. So it's going to be 6 minus 5, which is here. Then 2 minus 3, which is this one here. So what is 6 minus 5? I get 1. That's why it is a power 1 here. What about 2 minus 3? I get negative 1. But because I don't want the negatives, this negative 1 is for b. So if I take it in the denominator, it becomes a positive 1. That's why my answer becomes what? Becomes 9a over b. Becomes 9 what? Becomes 9a over b. I don't know if you have any question here. Becomes 9a over b. Becomes 9a over b. That's my answer. Okay. Any questions, guys? Please ask. Don't have any question? Let us look at our last example. Then you get something to try out. Okay. Now, our last example here, it is this one here. It says, open brackets, 2x power 3 divided by 8x power negative 4, then power negative 3. Now, if you remember our first part, we said that the power affects both the numerator and the denominator. Now, and we are going to see that this power is going to affect both the 2 and the x power negative 3. Okay. Now, however, to make our things simple, we say this is negative power. We're going to first swap the numerator and the denominator, like we said. Hope you still remember that. We said that this one, I'm going to put it here. Okay. And then this deno becomes what? Numerator. So when I swap them, now the negative 3 becomes what? A positive. That's what I do here. That's what I do here. Now after that, again I said negative somewhere. So what do I do? Now this negative 4 is for only y. So if I take it in the denominator, it's going to become a positive power 4. So I'm going to be having actually, it's going to be now what is 8 divided by 2, by the way? I get 4. So it's going to be 4 here divided by x to the power 3 and then y to the power 4. Let me explain this again. I'm saying that if I divide 8 by 2, I get my 4. Now this power here, it is that's the 4 which you see here. This power here is negative 4, but because it is in the numerator, I take it what? In the denominator, it becomes a positive power. So that's going to be x over x power 3, then y power 4. Now again, this power outside, I'm going to use my rules again. I'm going to be 4 to the power 3 divided by x power 3 times 3, and then y power 4 times 3, because we said that the exponent outside the brackets affects all the variables in the brackets. Now 4 to the power 3 is the same as 64, and 3 times 3 gives us what? 9, and the 4 times 3 gives us what? 12. Okay, I hope you understand this. Please, if you understand this, I want you to try this activity. Now this is the first exercise for grade 11 and it's a revision of grade 10 exponents, so please try it out. I'm sure you will enjoy the exercise. This is also part of exercise here, part of it here, and it ends here. Okay, so thank you so much for watching. Now in our next video we start with the corrections for this exercise. Thank you. Enjoy your holiday. Bye bye.